Okay, so in this class, we're going to do with two questions, 29 and 36 on your tuition note, okay? I'll start with 29. Draw the ray diagrams for formation of images by a convex mirror. In our previous class, we have done on concave mirrors. Today we're going to do on convex mirrors, doing the same thing that we did last time, that is stating the position, nature, and the size of image for each of the cases, okay? So let's start with the case 1 here. Case 1, okay? So take your pencil scale and your compass has to be ready for this, just like you did for concave. Then let us draw the convex. Like we did in the last class, we have to remember that our mirror is facing left. What do we mean by that? Like last class we did here. Now we have a convex mirror here, as you can see from your camera. Here, this side is the reflecting side, should face left, just like we did for concave. And this side, which do not reflect light, means the side from here we cannot see our image, that is the non-reflecting side, should be on the right side, okay? So we're going to follow that. So this side is bulging out, so that is convex. So how do we draw that? So last time we did from C this side, but this is convex, so C will be on the right from today, okay? So mark your C and take around, let us say 6 centimeter is a good distance. Now that's just a suggestion, it's not compulsory. And put your center of the compass here, and then you draw an arc like this today, like this. Like I said just now, the non-reflecting should be on the right side. That means that the oblique lines indicate non-reflecting side, so the line should be on the right side. Last time concave was also line on the right side, but C was not on right but left because it was concave like this. But today the ball is like this, right? So the center of the ball cannot be this side. Some people draw convex like this, and that's a mistake, okay? Now you see they put the C here. Now think about it. Now the shape of a ball is like this. Center will be inside, not on the right side. But they draw it here, which is wrong. So be careful. This is look at the curve and you will know where the C is on the right. Center of the ball, from where the mirror is taken out, okay? So this is what we make sure, that reflecting side is facing left. And then we know this middle point of the mirror is called pole, and half of 6 distance is, with your scale, 3 centimeter. Take your 0 here, and at 3 centimeter, which is halfway, you mark your F. So that is our ready now. Now, last time in the case of concave, you see here, in the case of concave, it was like this, just like convex with the lines on the right side. But the ball is like this, so the C was this side, F was here, and P. So we could place the object at infinity, 1, beyond C, 2, at C, 3, C and F, 4, at F, 5. Between P and F, 6 positions were possible because F and C were on the left side. But you will notice that F and C is not on the left side this time, not on the reflection side, it's back side. So we have only 2 positions, at infinity and between P and infinity. So we'll have only 2 cases. So the first case is object placed, let us say at infinity. So write that down and follow with me. So at infinity, now we learned that suppose this mirror is focused towards a tree at a very far place, that is called object at infinity. So let us say the object is at infinity, then the rays initially diverge. Many rays will come out, and since they have a long way to travel, they become parallel to each other. We discussed this in the last class. Same thing is here. Object is at infinity, so let us say one ray from the tree at infinity come parallel to the principal axis. This is from the object, incident ray, okay? Parallel. So how do it reflect? Put your scale here and here. And then with your pencil, on the left side, you draw full line. Don't move your scale on the same straight line. Draw broken lines on the right side of the mirror. On the right side, broken lines. On the left side, full line like this. Now please remember, as I said just now, this whole thing should be on the same straight line. So the ray will come and reflect like this. This is the actual reflected ray direction, mark it. And this ray look as if it's coming from F. It's not coming from F. It's coming from here and bouncing. But because of the direction of bouncing, it look as if it's coming from F, as if. Now take another ray. Let us say another ray came parallel to the principal axis from the same tree at infinity. These two rays are coming from this tree. These two rays, let us say. So again, put your scale here and here. And then draw like we did just a moment ago, broken lines on the right side. And on the same straight line, draw full line on the left side of the mirror. And this is the reflected ray. Now what do you notice? These two reflected rays look as if they're coming from the same point here, see, from the focus. So the image is exactly at the focus, right? So form on the right side at the focus. So let us write like we did for concave last time. Position first, so image is, no? Okay, dot dot. First is position, is formed exactly at F, right? Exactly at F, and it is behind now. Behind or right side? You will agree, right? See, this is in front, left side is in front, right side is behind. So from behind or right of the convex mirror. So the position is behind the mirror at F. And how about the nature? Now this image is formed by broken rays, means they are not real rays. So we call that one as virtual image, right? Virtual and erect. Virtual and erect means it will be upright. Top of the tree will be top in the image also. And the size is just a dot so small that we will have to say highly diminished. Okay, highly diminished. So that is the size of the image. So position here, nature virtually erect, and size is highly diminished. Case 1. Okay. Now let us go to case 2. Having done this, so there is only two positions possible because F and C are behind. Not on the reflection side, they are here, F and C here on the, so we cannot place the object on the right. That's why there are only two positions. Okay, so case 2, object placed. Okay, object placed between infinity and mirror, or some textbooks say P, between P and infinity, or between infinity and mirror. You can say whichever way you like, you can write it. So let us draw the convex mirror. By now we know how to do that. So here you see. Then here, this is convex, so we have to mark the C on the right. If it is concave, we mark C on the left and draw like this. But if it is convex, and we draw like this for concave. But for convex, we put our C right side and draw arc, let us say 6 cm this side, and then we draw this way, right? And then half, this is P, and half of 6 is at 3. You can mark your F. Halfway, F is always midpoint of between P and C. Okay, so now the object is not so far from the mirror. Now it is somewhere here between, not infinity also, not touching mirror also. So top of the object, bottom of the object, let us say this is a burning candle, because that will be easy to get an image. And then what type of image will it give? Let us see. So draw a ray parallel to the principal axis. Okay, then this is the incident ray. We know the rule, it will go to focus if it's concave, or if it is convex, then the parallel ray will look as if it's coming from focus. So broken rays you draw on the right, full on the left, and this is the actual reflected ray, right? So do that. And then we need two rays to get an image too, right? So put your scale at top of image, top of object, and see like this, like we have been doing. Draw full line left side and broken lines on the right side, passing through C like this. And we'll explain it. Look here. Now we learned in our previous ray diagrams also that a ray going towards C, this ray is going towards C. After striking mirror, it will bounce back on the same path and go this way. So the reflected ray cannot penetrate a mirror. No light ray can go through a mirror. So it will bounce back because it's going towards C. After striking mirror, it will bounce back along the same path. We know the rule. And this ray reflected ray look as if it's coming from C. Now these two rays are never going to meet because they are diverging. See arrow here. Going to go more away. So they look as if they are meeting here. As if they are meeting here. Intersection backward. So that is the point where the image will be formed. Exactly. Top of the object here. So this also will be the top of the image. This will be the bottom of the image. So this is your image. Right? So now we can write there. Image is formed where now? Between P and F. That's correct. So we write here image is formed between P and F, or you can also say F and P, okay, but it is still behind, and it is right side behind the convex mirror. We know that it is virtual in erect. You see up and up, image is also up there, like the object, virtual in erect, and highly diminished. This time it is slightly bigger, so diminished. So we saw in case 1 also it was behind mirror, virtual erect and highly diminished. Here also behind mirror, virtual erect and diminished. So we see that convex mirror can form only one type of image. Behind mirror, virtual erect and diminished. It cannot form, what I mean is, real inverted and real inverted image in front of the mirror. Impossible. So convex mirror forms only one type of image. What is that? Virtual, behind the mirror, virtual erect and smaller in size, right? For example, this position between P and F, I'll show you here. Please observe it here. My thumb size, you can see here, right? The real thumb size from the camera you can see. Now see the image, virtual erect behind. So behind this mirror, you'll see the image of my thumb. Isn't it smaller? You just check it once. Compare with the real thumb size and see from the camera. Okay, let me just check it. There. Can you see their image behind the mirror? See, it's clearly smaller than the real thumb size you can see on the camera, and the image behind the mirror is smaller than. So always behind mirror, virtual erect and smaller, diminished, you see. And convex cannot form real inverted, and it cannot form in front, okay? So that we have to keep in mind. Now you see, when the object was at infinity, it was at F. Right. Now when you brought it closer, you see, between infinity and P means the image was at infinity very far. Now it's near, we brought the object nearer to mirror. What is happening to the position? It's coming between P and F. So what does that tell you? It tells you that as the object was at infinity, image was here at F. But when I brought it closer here between P and F, image has moved away from F and towards P. So that is the position. So what happens if a question comes saying, as an object is moved away from a convex mirror, what happens to the position of the image? Then your answer is the image begins to shift towards P or away from F. Then what happens to the size? When the object was infinity, it was highly diminished, you remember? Right now. But when it was brought closer here, the image is slightly bigger, diminished. So when an object is moved away from a convex mirror, the size of the image, when an object is brought closer to the convex mirror, the size of the image increases and the position shifts towards P or away from F. That's your answer, okay? So having done this, we'll go to the next video for the next question here. We have done this. So today, we have completed your formation of image by convex mirror, okay?